This cyber operations and risk assessment briefing is intended to identify operational security risks posed to the Australian Five Eyes team in its current state, evaluate the benefits and costs of improvements, and provide recommendations to organizational leadership with regards to their software assurance needs. This presentation has three sections. The first section, Software Assurance Needs, provides a summary of the security requirements of the organization with regards to operating systems, application, and mobile device software. The second section, Operational Status, evaluates the existing software development lifecycle, SDLC, used by the organization. It also examines the present supply chain risks and software vulnerabilities facing the organization. The third section, Recommended Improvements, provides an evaluation of three remote management and monitoring, RMM, and mobile device management, MDM, tools, and provides a recommendation for the solution that best fits the organization based on its costs and benefits. This section also provides recommendations for minimizing supply chain risk. The Australian Five Eyes team has a strong need for software assurance and has a low tolerance for risk. A cyber attack, as witnessed with the recent ransomware outbreak, has the potential to impact the organization significantly. Since the summit is a brief event, any time taken to recover from a software exploit that impacts systems availability is time the organization cannot afford. Therefore, emphasis on mitigation of threat vectors is paramount and expected. It is furthermore the expectation of the organization that software functions as intended, free of malware and vulnerabilities. Any known software vulnerabilities should be mitigated prior to operational acceptance. The SDLC used by the organization to develop its software systems adheres to the waterfall model, but borrows key aspects from the Scrum model. The waterfall model components divide its methodology into 6 steps: requirement gathering, system design, implementation, testing, deployment, and maintenance. Although in the waterfall model, tasks are in a logical workflow that allow for high visibility among stakeholders, this model's rigidity, for instance the fact that testing occurs after the implementation phase, makes it difficult for timely improvements to occur. The organization therefore has adopted some aspects of the Scrum model into its SDLC, with emphasis on 1-month deadlines for milestone delivery and frequent check-ins among stakeholders. This balance is designed to ensure that operational security is an area of focus during the development and maintenance of the organization's software systems. The workstations, servers, mobile devices, and other electronic devices should be sourced from trusted suppliers. Doing so will reduce the risk of having a malicious embedded hardware module pre-installed at the manufacturing source or during transit from the manufacturer to the destination that could compromise the confidentiality of the organization's data. Some electronic devices in use by the organization are supplied through unvetted suppliers, and so potential risk does exist within the supply chain under the current hardware sourcing model. Nearly all software must be continually updated with patches that are provided by the software vendor in order to mitigate vulnerabilities that arise after the software has been released and deployed. This applies to both the operating system and specific application software that runs on the workstations, servers, and other devices. The organization applies all applicable software patches upon device deployment and emails end users with instructions of how to manually install updates as needed when new security patches are released by the vendor. This current model of software patch management is prone to error, infeasible to manage, and the recommendations for its improvement are found in the following sections. The organization should explore the use of remote management and monitoring (RMM) tools to manage the regular deployment of software security patches. For mobile devices, mobile device management (MDM) solutions should be explored and weighed according to their utility versus cost. Use of RMM and MDM systems greatly reduce the risk of software vulnerability exploitation by automating the installation of critical security patches. Option number 1, Kaseya VSA, is designed to manage endpoints, workstations, and servers through the use of a software agent installed on each device. Through the agent, systems administrators may deploy software security patches either on a recurring scheduled basis or on an as-needed basis for critical updates. Use of Kaseya VSA agents requires a licensing fee that is determined by the quantity of endpoints on which the agent is installed. The organization has recently considered deploying a Cisco Meraki firewall to protect the network perimeter at future summits. If the organization goes this way, the MDM solution provided by Cisco Meraki can be used to enroll and manage mobile devices connected to the organization's local network. In this way, the organization can maintain a high level of visibility into potential software vulnerabilities, as well as detailed network traffic statistics of its connected clients. Microsoft System Center Configuration Manager, or SCCM, is a system management software which, like Kaseya VSA, can be used to manage and deploy software security patches. Since the organization uses Microsoft Windows already on its workstations and servers, SCCM would be a natural fit and would be able to manage these workstations as part of the Microsoft Windows domain. The cost of SCCM depends on the number of client access license, CAL, in use by the domain. The recommendations for RMM and MDM software and supply chain risk management do not come without costs. RMM and MDM software, such as those evaluated above, incur licensing costs depending on the number of endpoints that are to be managed. Supply chain supplier investigation and approval is a process that will require many man-hours of research. However, the vulnerabilities that persist by failing to improve these operational systems increase the risk of a high-impact incident and should be mitigated using the following recommendations. SCCM, when combined with Microsoft Intune, can be used to manage mobile devices and workstations alike. Because the organization is already invested into the Microsoft Windows environment, and because SCCM also supports mobile device management, SCCM is the recommended solution for this organization. The suppliers from which the organization sources its hardware have not been vetted with supply chain risk in mind. Therefore, it is recommended that the organization discover the countries from which its electronic components are sourced. It is also important to discover the route that electronics take during shipping and consider disallowing suppliers that ship using routes through known adversarial countries, such as Russia. Suppliers should be required to provide evidence that electronics were not tampered with during transit using security stickers and other methods. All received electronics should undergo physical inspection to minimize the possibility of a secreted hardware module designed to exfiltrate sensitive information. The organizational leadership should weigh these options and develop a formal policy for vetting and improving each supplier it uses and remove any non-compliant suppliers from the supply chain. The current cyber operations of the organization, while doing well at combining the Waterfall and Scrum SDLC models, presently are accepting of too much risk with regards to supply chain risk and software vulnerabilities. These weaknesses are in part responsible for the recent ransomware breach that was experienced during the 2019 summit. By implementing the recommended improvements previously detailed, the organization will improve its security posture and be better positioned to deploy regular software security updates and minimize the risks implied within its hardware supply chain.